Welcome back to our module 3 of Apache PySpark series, which is data processing with RDD and DataFrame. First question is, what is RDD, DataFrame and Dataset? So RDD is a list of data spread across the cluster in Spark. So full form is resilient distributed dataset. So it is just a list of data objects, okay, spread across the cluster. It is in raw form, okay, so it is not optimized. It is not optimized means it is definitely slow, okay. So RDD is in very raw format, that is RDD. And let's say same concept, just data will be in table format, that is data frame, okay. Same as RDD, just data will be in not raw format, it will be in table format. So data frame is a list of data spread across the computers in Spark, just in table format, row and columns format. It is in table format, so it is optimized. It is optimized means it is faster than RDD, okay. And data set is same as data frame, okay. Just it has type safety, okay. Data set is same as data frame, just with type safety. That means if any column type is integer, okay, and you are treating it as string, then Spark will throw error, okay. So RDD and DataFrame is not type safe, but dataset is. And same as our DataFrame means table data will be in table format across the cluster. So I will repeat one more time. RDD means list of raw data objects. DataFrame means list of objects but in table format. Dataset is also list of objects in table format but with type safety. Now next is how can we create data frame in using Apache Spark, okay. So this is the code, but let's understand it. Let's say we are creating our manual schema, okay. We are not importing data from anywhere, we are creating our own manual schema. So first what we are doing is we are importing these different classes, okay, which will be useful for creating schema. Struct type, struct field, integer type and string type, okay. These are the classes which we are going to use. Then it is nothing but a list of Python tuples, okay. It represents a row, each and every row, okay. This will be the data present in the rows, and then we are just creating the schema, okay. So we are using these classes struct type and struct field. So this represents the name of the column, type of the column which will be integer, and true means null values are allowed, okay. The name of the second column is name, type will be string and null values allowed. Third name is age, type is integer, null values are allowed. Then we are finally creating this data frame using create data frame. So basically we are converting this tuple into proper data frame understandable by Spark. We are passing this data and schema objects which we have created here, okay. Finally we are showing a data frame means we are printing the data. Now let's try that in notebook. You can use any notebook like Jupyter notebook or Databricks, but Databricks will be good. You can use free edition. Okay, this is the community version where you can use these notebooks for free. So you just have to log in with your Gmail or anything, and then inside workspace you just have to create one workspace. Okay, it is very easy, so I'm not going to teach you that. And then simply after creating notebook you can practice like this. Okay, so I will just, we have understood the code and now we will just copy it. That's it, copy and paste in the cell. mm, why it is not taking? Yeah, control V. Now we will just run it thing. Yeah, this is the run button. It is connecting to the cluster. Now it is running this code. The output will be visible here. Okay, Databricks free edition. This is the output. This is our data frame which we just have created manually. Now next is upload your own CSV. So how can we do that? So inside Databricks there are many sample database. So for practice purpose we will only use that. Okay. So we are using this read.csv method, and here we are passing the address of the file. Okay. Header true means first row will be column titles. Okay. Infer schema true means Spark will automatically detect the data types. Okay, it will infer the data types. And inside this show method we are passing 5 means we just want to show 5 rows as of now in our data frame. So let's try this in our notebook. Copy. I think we can delete this earlier. We will use new cell and just paste. Okay, so it will print 5 rows of the first 5 rows of this CSV file present inside Databricks. Run. It is working as expected. Okay, so we have loaded the CSV file same way. We will create data frame from JSON file as well, present inside Databricks sample data. Okay, so here we are using this read.json method and we are passing the address of this sample JSON file present in Databricks. Okay, and then we are just showing complete data frame. Let's try this in Databricks notebook. Just create new cell Control V, run. Okay, so it is successfully showing this JSON file. So that's how you can create data frame from JSON file. Now we will quickly practice column and row operations. Okay, so for practicing this, first we will clear earlier data frames. Delete. Okay, all right, it is clear now. So for practicing column and row operations, we will create this new data frame. Control V. Okay, so these are the Python tuples representing rows. These are the name of the columns, and we are creating the data frames, and we are printing the data frame. Run. All right, our data frame is created. Now we will practice column and row operations. So first is select. If you want to select only limited certain rows, so not rows, if you want to select only limited columns, so that time you can use this select method. So data frame object dot select, and you will pass the name of the columns which you want to select and then print those. Okay, so let's try this. Okay, so it should show only name and age columns, and it is working. Now using this withColumn method, you can add new column. Okay, so first we will import this call function. Now we are adding new column in this earlier data frame. Okay, using this withColumn method, and then we are passing the name of this new column, age plus 5, and here we are specifying what data will be present in this new column. So call age means earlier existing age column plus 5. Okay, so it will add 5 in the existing age numbers. Okay, finally we are printing this data frame. So let's try this. Okay, so using this withColumn function, we have created this new column, and we are adding 5 in this existing age here. Okay, so this is also working. Now next is drop, means we can remove that column. So it is very simple. Just use this drop function and pass the name of the column which you want to remove. Control C. Control V, and that newly added column will be removed. Okay, working fine. Then next is filter. Okay, now we are starting row operations. So we want to filter the rows, and what is the condition for filtering? This age value should be greater than 30. Okay, so we are using this filter method on our data frame object, and we are specifying the condition that this value of this age column should be greater than 30, and we will print the data frame. Let's quickly copy it. Paste. Now in this age column, greater than 30 means it should only show Bob and David age. Yeah, it is showing Bob and David because age is greater than 30. Next is where, same as filter. Okay, we are changing the filter condition. Now age should be less than 30. Now age will be less than 30. Okay, working fine. Next is combine. Okay, so basically we are combining multiple row and column operations. So first we are selecting this name and age column using select method. Then we are adding new column with column method. Name will be age double, and the data present in this new column will be existing age values into 2. Okay, this will be our new column name, and values will be existing age values into 2. Then we are filtering age should be greater than 25. Okay, and finally we are printing the output. So let's quickly try this. Control V. Okay, so let's quickly check the result. It is selected name and age. So age double is our new column, and values are existing age value into 2. So 29 into 2, 35 into 2, 40 into 2. Then we will filter where age should be greater than 25. Okay, so age is greater than 25. Finally we are showing the data frame. Okay, so these are some column and row operations which we have practiced. Now next topic is handling duplicates. Okay, so how can we handle duplicates in PySpark? So for this, first we will need some sample data frame. So let's create that. So first we will connect our cluster. Create this sample cell, and now just paste this code. Okay, so first let's understand before pasting. So this is the data. Okay, it is Python tuples, list of tuples representing rows data. So as you can see, id 2 and id 4 is duplicate rows. Then we are creating columns. So these are the column names: ID, name, and age. Okay, these are the column names. Then we are converting this list of tuples into data frame using this function. Create data frame function we will use, and we will pass this data and columns object so that we will get our data frame. Finally, we will print our data frame. Let's copy. Okay, let's run it. So our data frame is ready. Sample data frame is ready. Now on this data frame, we will practice handling duplicates. So first is remove exact duplicate rows. Means on the data frame we will just use this function drop duplicates. It will remove all the rows with duplicate data. Then we will print our data frame. Let's copy. Create new cell and paste. So it should remove this Bob and David. Okay, because these are the duplicates. Let's run. So as you can see, in this data frame, duplicate data is automatically removed. Okay, this is only unique data. Now we will check our second function. Not second function, it is the same function drop duplicates, just based on ID. Okay, we will drop duplicates based on some selected column like ID. Okay, so only rows with duplicate IDs will be removed. So let's remove this duplicate. We will use same data frame, and now we will try this. Remove duplicates based on IDs. Control C, Control V. Okay, so it will not remove rows based on this age and name. It will remove based on these IDs. Okay, run. So we have our unique data. Duplicate IDs are removed. All the rows with duplicate IDs are removed. Now next is how can we rename column names using PySpark. Okay, so first let's clean our notebook. Drop duplicates, just remove this. Yeah, so let's keep it because we will use this same sample database. which we used while learning duplicates. Okay, so we will use this same dataset. Let's create new cell. So if we want to rename only single column, that time you will use this with column renamed function, and we will first argument will be existing name of the column, second argument will be new name of the column, okay, which you want to rename. This is existing name, this is new name, and then we will print our data frame. So let's copy. So this name column will become full name. See, this name is changed to rename to full name. Delete. Now how to rename multiple columns? This is not actually divide operator. This means continuation of the code, okay, in Python. So we are continuing this, and here we are not continuing. This is new line. Okay. So we are going to use this same function with column renamed. Existing column name, new column name, existing column name, new column name, and then we will print. Okay, so let's try. Copy. Paste. So ID age will change to user ID and user age. Okay, so we are changing this to, we are renaming this to column names. Let's run. So ID is changed, renamed to user ID, and age is renamed to user age. All right. Delete. Now how to rename all the column name at once? Now here we will use this different, this is not the same function which we used earlier. This is different function, 2df, and these are the, then we will pass the new column names. Okay, ID will be changed to this capital ID, name will change to person name, and age will change to person age, and then we will print our data frame. Okay, so let's copy, paste, and all three column names will be renamed: user age, user name, user ID, username, user age. Okay, sorry, it is not user ID, it is capital ID. So we have capital ID, person name, person age. All three columns are renamed. So in this case, we will use this 2df function. All right. Now next topic is aggregations, group by, case when, and window functions. So we will take couple of examples in each topic. So for practicing this, we will need some data frame, sample data frame. Okay. So first we are creating this list of tuples in Python, which represents our data in each and every row. Then we are creating this list of columns which our data frame will contain. Okay, order id, order date, category, city, status, amount. These are the column names. Then using this function we will create data frame. We will pass this data and calls objects, and here we are doing one thing. I will explain you that. So we are adding this order date, but in Spark by default it will be in string order, string data type. So we have to manually convert it to date data type. Okay, we have to convert it from string to date data type. So for this we will use this with column function because we are changing the data type of existing column. Okay, so order date, this is our existing column, and we will use this function app dot to underscore date, and we will pass the name of the column for which we want to change the data type. Okay, so order date data type will be converted to date from string. Finally we will check the structure of our schema and then we will print it. So let's try this in our Databricks notebook. So it is ready and it is connected as well to cluster. Now just copy and paste. Control V and it should do the work. Run. So our data frame is created and our schema structure is visible here. Okay, so you can see the data type of each and every column. Order ID is long, order date is date data type which we converted manually. Okay, category will be string, city will be string, status will be string, and amount will be double data type. So our data frame is created successfully. Now next thing is I want to group this table data into category. Okay, so all the electronics, all the groceries, clothing, this category will be grouped and we will perform some arithmetic operations. So data frame dot group by, this will group your data by category. Okay, now I want to perform some aggregate functions. So inside dot agg we will perform our aggregate functions. So first I want to perform the sum of amount. Where is amount? This last one is the amount. I want to perform sum of amount for each and every category. So I have dot sum pass the name of the column, and the name of the new column will be total amount. So I want to check how many rows are there for each and every order. So we all know that we will use count star for this, and the name of the new column will be num underscore orders. Okay, so basically we are checking how many orders are there per category. Same way we will calculate average of amount per category, minimum amount in each and every category, and maximum amount in each and every category. Then we will sort our result in descending order. But which column? This column. Okay, the numbers present in this column will be shown in descending order. And then finally we will show our table. So let's copy it. So I will repeat one more time quickly. First we are grouping our data frame with category. Then we will perform some aggregate functions. First we are performing sum of amount. We are saving it in this new column. Then we are checking how many unique rows are there in each and every category. Okay, and we are saving it in this new column name. Then we are performing average of amount, then minimum of amount, then maximum of amount in each and every category. Finally we are sorting the result by descending order in this total amount column. Okay, then we are printing. See, all our data is grouped with these categories. Okay, and we are getting total amount, number of orders, average amount, minimum amount, and maximum amount. Now we will check multi-column group by example. Okay, so let's understand with diagram. So earlier you gave me order related calculations in each and every category, but now I need order related calculations in category plus each and every city as well. Okay, so I want to create the group of category and city. So we will use this df dot group by, and we will add the columns which we want to group, city and category. So groups will be created like this. In Mumbai, each and every category will be covered. In second city Pune, each and every category will be covered. Okay, so on and so on. Now we can perform calculations because data is grouped now with city and category. So just give me the sum of amount in each category plus city. We will simply do f dot sum uh, amount to column where you want to perform the sum, and we will save it in this new column name. So result will look like this. In the city and category group, sum of amount will be shown here in this total amount, new column name. Now Spider-Man is saying people are causing trouble. Some are cancelling order, Some are claiming refund. So I want to check the count in each city and category group. How many orders are paid? Okay. So basically I want to check the count of paid orders in your city and category group. So earlier our data frame is looking like this. Some orders are paid, some are refund, some are cancelled. Okay. So basically I want to check count of paid orders only in city as well as category group. You have already grouped this, right? Here you have already grouped this in city and category. So in these two groups I want to check the count of paid orders. So let me zoom it. So it is something like if and else. If you know programming, you definitely know conditionals like if else. So same way we are using it, just different syntax. Here we are saying if status equal to paid, then return true. Otherwise return null. See, this is third column is status column. If status equal to paid, then return true, otherwise return null. And the new column name will be paid underscore orders. So basically, and then finally we will use this f.count on this statement. Okay. So this will return the count of paid orders in our city and category groups. Okay, true means 1 and null means 0. Okay. So the result will look something like this. Count of paid orders will be shown in the output. Understood? And count is only used for counting not null values. Okay. So instead of this paid, refund, cancel, if null is there, then it will not count. Okay. It will only count not null values. That's why we are using count. And if we only wanted to check number of rows, how many rows are present in each and every city and category group, we would have used count star. Okay. But here we want to count only not null values, so we will use count. And finally Spider-Man is saying table is looking messy without any order. Okay. So we will sort it alphabetically by city and by category. So we will use this order by city category dot show. So if you check the output, city is sorted in alphabetical order. Okay. Am first alphabetically am will come, then P will come. Then inside that group, you will sort the category in alphabetical order. So C, E, G. And in second Pune group, C, E, G. Okay. So we are sorting alphabetically in both the city and category group. Now we can try this statement in our notebook. So this is the example of multi-column group by. In this we will group two columns, not one. I think we can just delete this earlier cell. This is our data frame, okay. Status is fifth one. Yeah, so we will execute this. Okay. So city and category is grouped. Then we have this sum of amount in total amount column name. Then we are counting the paid orders, means where the status equal to paid. And the count is visible here in paid orders new column. Then finally we will sort alphabetically in city and category. Then we will show our table. Let me repeat one more time. So earlier we were only grouping with category. Here we are grouping with both city and category. Now we can perform aggregate functions on them. So inside .agg we will use f.sum on this amount. This amount, last one, okay. And we are saving it in this new column, total amount. Then I want the count where status equal to paid. So we will use this conditional if status equal to paid in the status column, then we can return the true. Otherwise we can return false, not false, null. And we will save the result in this paid order. And I want to count where the result is true. Okay. Count will only count where result is true. It will not count null. So we have our count of paid orders. Finally, we will sorting our result with city and category alphabetically. Okay. C, M and P in the city. Then each and every city group we have C, E, G, C, E, G. It is sorted. And finally, we are printing other result. Next is multi-aggregations with .agg and named expressions. So in this first topic will be dictionary style aggregations. So check the diagram. Spider-Man is facing some issue. He is saying, bro, agg method, we are passing all the aggregations, but it's looking messy. So is there any alternative? So first check the first diagram, left hand side diagram. We are doing group by category and then .agg inside that method. We are passing all our aggregations one by one, like sum of amount, count star, average of amount, etc. But it is looking very messy. So is there any alternative for that which will be short and reliable? Now check the right hand side diagram. Yes, the solution is we can create the Python dictionary object. Okay. So in this Python dictionary object, we will use key and values. So first key and value is amount and sum, means on this amount column we want some aggregate function, and star is key, count is value, means I want to count all the rows in each and every category. Okay, because first we have already grouped it with category. So that's how we can create our dictionary object. And then df.groupBy status. Okay, so here we are grouping with status, and dot agg, inside that method we will just pass this dictionary object. Okay, so it is looking neat and clean. In the left hand side you can check it is all messy. In the right hand side we are just creating the Python dictionary object, and we are passing our key and values. So we are passing our aggregate functions in the form of key and values. That's why it is neat and clean. And then inside the agg method we will just pass this dictionary object instead of writing line by line aggregate functions. So this is the solution. Now we will check this code in our notebook. So we are creating our dictionary object first. We are applying sum on amount column. We are applying count star, means each and every row in that group. Then we are with column renamed, means we are renaming the column. And then finally we are just showing the result. So we will try this in notebook, you will understand it better. So cluster is connected. This is our sample data frame, okay, which we are using. Now just copy paste. Oh, we have to use hash. Okay, for comments in Python we use hash, not double slash. That's why it is showing error. We will quickly fix it. All right, so we have created this Python dictionary object. We are saying apply sum on amount column, means this amount is the last this column, and then count all the rows in that particular group. So here we are grouping our data frame with status. Okay, so now Spark will calculate aggregate function separately for each and every status. So inside this agg method we are just passing our dictionary object, which is this, and then we are renaming columns because inside dictionary object we cannot pass alias. That's why we have to do it separately. So using this method we will rename the column. Sum of amount will be renamed as sum underscore amount. Count 1 means count star. Okay, count star will be renamed as row underscore count, and finally we are showing our data frame. So let's run it. DF is not defined. Actually, I am starting this after like 4 and 5 hours. So we need to run this first cell as well, where we are creating data frame and where we are creating our DF object. Okay, DF means our data frame, which we have created this sample data. So we need to run this cell as well. Then only that DF object will be created. Okay, so I think it should work now. All right, it is showing the result. Okay, so it is grouped with status paid, refund, and cancel. And we are performing sum of amount for each and every status. And then we are counting rows for each and every status. Okay, so it is working fine. So this is how dictionary objects works. Now what is conditional aggregations? So Spider-Man is saying, bro, as of now I have learned that how simple aggregations works. Like I can group any rows. Okay, then I can perform simple aggregations like I can sum all the amount. Okay, but let's say there are some additional conditions, like check this database in the right hand side. So I have to group with category. Okay, category is third. Then I have to perform sum for each and every category. That is also easy. This fifth column we can perform sum for each and every category. But only when the status equal to paid. Okay, I have to perform sum for each and every category, but I have to check this status column as well when status equal to paid. I don't want to sum when status equal to refund or status equal to cancel. So this is now additional condition. Now in this case we will use conditional aggregations. Okay, so this is the syntax. First we are grouping with category. Okay, then we are saying if, check the second line, if status column is equal to paid, then only take the amount, otherwise take 0. Okay, and then add those amount for each and every category because we have already grouped with category. Then second, if in this status column, if status equal to refund, then take the amount, otherwise take 0, and then add those amount for each and every category. Okay, amount will be added only when status equal to refund, otherwise it will take 0. And third is, we just have to sum all the amount for each and every category, and then we are using alias, like we are giving name to this new column. Okay, finally we are sorting by category in ascending order alphabetically. Okay, and then we are showing the result. Got it? That's how you perform conditional aggregation. Now quickly check the code. So first here we will group our data frame with category. Okay, now we will use conditional aggregations. So inside this AGG method, if status equal to paid, then only take the amount, otherwise take 0. Okay, after that add all the amount for each and every category. All right, otherwise, yeah, now spelling is correct. Similarly, second is also same. If status equal to refund, then only take the amount, otherwise take 0. Then for each and every category add that amount, and we are giving alias. Okay, we are renaming the new column. And third is very simple, we just want to calculate the sum of amount for each and every status, not status for each and every category. Okay, then we are sorting alphabetically with category, and then we are showing the result. Now let's try this in notebook. I think I would delete this second cell. Now just copy paste the code. Okay, execute. We got it. It is grouped with category. Okay, it has added all the amount when status equal to paid, which is paid amount. Second is refund amount. It has added all the sum when, sorry, it has added all the amount when status equal to refund. Finally, it has just added amount for each and every category. There is no additional condition, and we have sorted this with alphabetically by category. C, E and G. This is alphabetically sorted. Then we are showing the result. Now next is pivot transformation. Okay, so let's say I have status column in my data frame, and it has three different types of values: paid, refund, and cancel. Now I want to turn them into individual columns so that I can compare. So what is the solution? The solution is pivot transformation. Okay, so let's quickly check the code. Here we are grouping the data frame with city and category. Then we are using pivot method, and we are saying inside this status column I want to turn this paid, refund, and cancel values into individual separate columns, and I want to fill those columns with sum of amount. Okay, so in that column amount will be added for status equal to paid. In the refund column amount will be added for status equal to refund. In cancel column sum will be performed on this amount where status equal to cancel. Finally we will sort with city and category, and then we will show the output. Let's quickly copy paste. So we will just paste it in our notebook. Let's delete this earlier cell. Now just paste. Okay, see, we have three new columns with those status values. All right. So next is roll up and cube. So first let's check roll up. So Spider-Man is saying as of now you were just doing calculations for normal grouping. Okay, we were just grouping the data with category and city, but now I want to drill down the result with hierarchy. Okay, I want to drill down the result with hierarchy of category and city. Means we will perform subtotals and also we will perform grand total. Okay, so basically we are trying more combinations rather than normal grouping. Okay, so if you check the table here, see, in roll up null means this is the grand total. Okay, 7399 is grand total. Let's zoom it. After that we are trying this category to city hierarchy. For each and every category city will be tested. So first category is clothing. So with clothing we are trying null Mumbai Pune. Okay, then second category is electronics, we are trying null Mumbai Pune. Same for grocery. Now what is cube? Cube means we will try each and every possible combinations. Each and every dimension we will calculate. Okay, so each and every, if you observe the table, all the combinations will be there. See, first is grand total. Okay, so all the combinations will be there. So now quickly jump to the code. First we will try this roll up. Copy. think we can delete this pivot transformation. So first we are trying rollup method for this hierarchy, and we will get subtotal complete grand total as well. Okay, this is our grand total, and then after that we are following category to city hierarchy, and all the combinations are there. Then we will try cube. Here we will get all the combinations. Control C. See, we are using cube method on these two groups. Then we are performing aggregate function sum of amount. Here we are renaming this new column, and then we are sorting with category and city alphabetically. Run. See, each and every combination will be there if we use cube. Now we will check window functions. So what is partition? Spider-Man is saying for each and every city, this is all sample data frame, right? So for each and every city, I want to check all the orders which is sorted by order date, so that I will practice window functions on each partition or each group. So what is the solution? We will partition data into separate groups based on city. Okay, we will create partition city wise, and after that we will sort it by order date. Result will look like this. So this will be our Delhi partition sorted by order date. This will be our Mumbai partition. Okay, so our result will look something like this. Now quickly check the code. We will use this window dot partition by city. Okay, separate partitions will be there for each and every city, which will be sorted by order date. All right, and this is our partition object. Quickly copy. We can delete this cube. This is roll up. And yeah, this is our sample data frame. Control V. Okay, so it is successful. You can check the right tick mark. Now you have your partition data frame. Okay, partition by city. For each and every city you have multiple partitions. So now Spider-Man is saying you have your partitions, but I want to give unique increasing number to each and every row in separate partitions. Okay, in each and every city partition I want to give unique increasing number. So what is the solution? Solution is this row number function, window function. We will use DataFrame dot with column. This will add new column. Name of the new column will be Rn. Then we will use this row number function on this partition object. this is our partition object. Okay, I will just show you. W underscore city, this is W underscore city underscore date. This is our partition object. Here we have partitions for each and every city and sorted by date, order date. So we'll give this row number 1, 2, 3, 1, 2 in each and every partition. Result will look like this. See, for this Delhi city we have one partition, and each and every row we have increasing number 1, 2, 3. Now Mumbai, this is second partition. We have row number 1, 2. Let's quickly check the code. Copy. Control V, paste. We should have row number for each and every partition. See, this is Mumbai city partition. We have 1, 2, 3, 4, and the remaining is Pune city partition. 1, 2, 3, 4, 5, 6. Okay, so this is how you use row number. Now next question is rank. So we know that we have our data partitioned. Okay, so for each and every city we have separate partitions, and that each and every partition is sorted by order date. All right, now check this diagram. Spider-Man is saying please give rank to order dates. If two order dates are same, then they should get the same rank, and next rank should be skipped. Okay, I will repeat again. If two order dates are same, they should get same rank, and next rank should be skipped. So check the second diagram. See, order date is 1123. Check the right hand side diagram. We have rank 1. Now again 1123. So these order dates are same, then again it should get same rank 1. And see, next rank should be skipped. So after 1 there will be 2, but for this 1, 2, 2023 order date we will use 3, because in rank function next rank is always skipped. If two order dates are same, they will get same rank, and next rank should be skipped for next date. Alright, let's quickly jump to the code. So we have our data frame. Okay, let me connect to the cluster, because it's been one day. Now I am starting again. So every time you need to connect to the cluster and run this each and every cell, because after that only that data frame will get created. This df object we need. First cell is run, data frame is created. Now we have created this partition. Okay, using this partition by method. So we are partitioning separate for each and every city. Okay, we have separate partitions for each and every city, and that is ordered by order date. So execute this as well. Now we will give rank to each and every order date, and same dates will get same rank, and next rank will be skipped. Let's quickly copy the code. Control V. Okay, so we are using this withColumn function for creating this new column. Name of the new column will be RK, which is rank. Then for giving rank, we are using this f.rank function on this window object, which contains our partition data. Then we will check the output. This object we are using, okay? Alright. Now you can check each and every order date will have rank. If order dates are same, then they will have same rank, and next rank should be skipped. So after 2 there won't be 3. Okay, it will be 4. So for Mumbai it is done. This is our first partition. Then for Pune this is second partition, and check 9125 9125 we have rank 1. Then 9225 we have 3. Okay, this is how rank works. Next is dense rank. It is actually same as rank function, just next rank will not be skipped. So see, if two order dates are same, they will have rank 1, but next rank will have rank 2. Rank will not be skipped. Okay, so see what Spider-Man is saying. Please give rank to order dates. If two order dates are same, they will have same rank, but next rank should not be skipped. Okay, so we know that for each and every city we have different partitions, and each partition dates are sorted by order date. So let's take this example. Let's say we don't want to give rank to order date, we want to give rank to this amount. Okay, so Mumbai, this is our first partition. For 300 we will give rank 1. For 200 amount we will give rank 2. For 200 again we will have same rank, okay, because data is same, amount is same. Now for 100, next rank will not be skipped. Okay, in rank function we used to skip one rank. So if we are using rank function, then it will be 4, but in dense rank next rank will not be skipped. So for 100 we will have rank 3. Now this is second partition. For this for Pune, for 400 amount we will have rank 1, for 100 we will have rank 2. Understood? Now quickly check the code. Copy, so we are using this withColumn function. We are creating new column. The name of the new column will be dense RK, and then we are just using this dense rank function on this window object which we created earlier, which contains the partitions for each and every city sorted by order date. In this example we will give dense rank to order dates, okay, for each and every partition. Run. See, this is first partition for Mumbai. So where is order date? Yeah, 9 to 25 rank 1, 9/3 2025 rank 2, 9/3 again 2025 means same 2. Now 9/5 2025, next rank is not skipped because this is dense rank, so we will give 3. If we were using rank, then we would have skipped this. It would be 4. But we are not using rank, we are using dense rank, so it will be 3, not 4. So same way, this is second partition. We have ranks for same dates. If date is different, we are giving different ranks. Okay, these are same, so we are giving 4. So this is rank function and dense rank function. What is lag function? So Spider-Man is saying, I want to compare amount side by side. Okay, so can you please add a new column which will store previous rows amount, first previous rows amount. Okay, so what is the solution? Solution is lag function. Check this second diagram. In this sample data frame, we are adding this new column called prev underscore amount, and we are storing earlier first previous amount. So first is 500. Okay, so it does not have any first previous amount, so it is storing null, but after that previous amount is getting stored properly. Okay, so in the second row, first previous amount is 500. In third row, second previous amount is 300. Okay, and in Delhi, which is the second partition, first will be null, second will be 2 minus 1, which is 400. Okay, so first previous amount we can store. Let's quickly check the code. We are using this with column functions, and we are adding this new column. Then we are using lag function. What do you want to perform in lag? So on this amount column, I want to store first previous amount. Okay, from this amount column, take first previous amount. Okay, this is our window object, and we are showing the result. Let's check the code. So this is our sample data frame. This is the partition. Data frame is partitioned by city. It is not connected. Connect. Okay, so copy this code now. Copy, and we can just paste here. So first previous amount will be stored now. Okay, we need to run this data frame again. What we can do is run all. First data frame will be created again, and then we will partition the data frame with city, and then we will perform lag. Done. See, it is storing first previous amount. Let's say if you add 2 here, then it will store second previous amount. Okay, so this is our lag function. Next is lead function. So it is basically opposite of lag. In lag we were storing first previous amounts. Okay, in lead we will store next row values. Okay, and bring it to the current rows. So Spider-Man is saying I want to look at the next row value and bring it to the current row. If no value is in the next row, then we can return null. So check this diagram. Let's say if it is the sample data frame, then we are storing the next value in the current row. Okay, 700 is the second value, so 700 is stored. Then third amount is 600, so 600 is stored in second row, like that. So using withColumn function, we are just adding this new column. We are using lead function on this amount column. So we want first next value. Okay, if we write 2 here, it will take second next value, but we want first next value, so we'll write 1 on this partition window object, and we will show the result. Paste. It is working fine. See, for this first partition, which is Mumbai, it is storing 650 in the first, 1500 in the second, 300 in the third, and fourth we don't have any other row in the Mumbai partition, so it will store null. And similarly, it will perform the same for this Pune partition. Now our next topic is cumulative running totals. So first we'll see running sum. So Spider-Man is saying, please take all the rows from the first row in the partition up to the current row and perform sum of amounts. Okay. So in each and every partition, we have to take first row till the current row and perform sum. You will understand in this second diagram. So let's say we have our Delhi partition. So check the first row. So current row and first row will be same. So we will store 100. Okay. Now current row is second row. So take the data from amount from first row till the present row and add the perform the sum. So 200 plus 100, 300. Now present row will be third row. Take the values from first row till the present row and add all the sum. So addition will be 600. So like that we will perform. So we will use this withColumn function which will add this new column. Then we will say that we want to perform sum of amount on this window object. Now this in this rows between function we will give our range. Okay. So this window class dot unbounded preceding means the first row and window dot current row means till current row. So we are giving range from first row in the partition till the current row, and then we will show the result. Let's quickly try this in our notebook. Run. Check what is the name of new column, running sum city. Okay, so it is running sum. So what is our first partition? Mumbai. So we will add present row. Present row is first row, okay, and first row is also first row. So it will be just 200. Now for 650, current row is present row is 650, and the first row is 200. Then we will add this 2 and we'll write 450. It is minus 200, that's why it is performing 450. Okay, if both are positive then it will add. Now what is the present row for our Mumbai partition? This 1500. Now from first row till the present row, so it will add this 3. Total is 1950. Now what is the current row? 300. From first row till the current row, so it will add this 4. Total will be 2250. Similarly, it will perform the same for second partition as well. Okay. Running sum will be performed separately in separate partitions for separate cities. Alright. Now next topic is running count. So Spider-Man is saying take all the rows from first row till the current row in each and every partition and perform count star. So count star will add all the rows. It will even add null. Okay. So whether it is null or not null value, it will add everything. Count star means perform count all the rows in each and every partition. So check this table. First partition is Delhi partition. So count will be 1. For this second row, present row will be second. From first row till the present row, count everything. So that will be 2. Okay. So again for second partition, which is Mumbai, this is the first row. So this will be 1. Now present row is second row. From first row till the second row, what is the count? Count will be 2. For third row in Mumbai partition, what is the count? From first row till the present row, 3. So this is 3. Now quickly check the code. Okay, I haven't written the code. So can we edit this? So let's quickly try this code in our notebook. Okay. Control V, run. Okay, so it is the running count from first row till the present row in each and every partition, which is Mumbai and Pune. Now next is moving 3 row window average. Okay, so moving average we will calculate now. So check the diagram. Spider-Man is saying take the current take the current row. Okay, then take 2 rows before the current row. Okay, that means total 3 rows will be there. Current row, 2 rows before the current row, and then calculate the average of amount for these 3 rows. Okay, so we know that for each and every city we have different partitions, so we will perform this in every partition separately. Alright, now check the second diagram. So this is our sample data frame. So now here, okay, check the first row. Amount is 100. But there are no rows before that. Okay, we have to take 2 rows before the current row, but there are no rows, so average will be 100 only. Now second row 200. So we have to take 2 earlier rows, but there is only one earlier row which is 100. So we will take that average only, 200 plus 100 divided by 2. This is 150. Now current row will be third row 300. Then take 2 rows before the current row, means 100 plus 200, and calculate the average of all three. So 100 plus 200 plus 300 divided by 3. We will get the 200 average. Alright. So this is how we will calculate moving average for these 3 rows. And one more thing, we will use this rows between function. And in this function we can give range. -2 means 2 rows before the current row. 0 means current row. So this is the range. 2 rows before the current row plus current row. Means 3 rows average we will calculate. Now quickly check the code. So this is our partition object. Now we will use this rows between function. We will provide, this will give us the range, -2 earlier rows, 0 means present row. Okay, so 3 row average we want to calculate. df dot with column means it will create one new column. Name will be this. And what we want to do is we want to calculate the average of amount column. On what? On this W trailing 3 average, means on these 3 rows, current row and earlier 2 rows. Alright. Then we are just sorting by city, order date, order ID, and then we are showing the output. That's it. Just copy. Let's check the notebook. Connected. I think we need to again run all this. Run all cells. If we take the long break, then we need to run all these cells again. Run all. Yeah, I think it is running perfectly. So we have this sample data frame. Then we have created this partition by city. Now we will calculate this moving rows. Run this. Okay, we have this moving average for current row and earlier 2 rows. If there is no earlier row, then same average will be there in this column. Now next is partition by multiple keys. Okay, so as of now we were like practicing on partitions only for the city. For each and every city only we have different partitions. But now we want partition for multiple keys, means multiple not multiple pair, single pair. Okay, city and category pair, like this partition we want. Okay, we want separate partitions for city category pair, not group, pair. So let's quickly check how our result will look like. So if this is our sample data frame, for each and every city category pair we will have different partitions. So partition 1 will be for Mumbai and food category. Partition 2 will be for Mumbai and clothes category. Partition 3 will be for Delhi and food category. So this city and category pair is there for each and every partition. It will cover all the pairs. You don't worry about that. So check the code. First we are doing partition by city and category, and we are sorting by order date. After that we are just using some window functions which we have already seen. It's just that we will practice on this multiple keys partition. As of now we have practiced on only single key partition, means we have partition by city only. Now we will practice partition by pair. So this, which function we are using? Row number. Okay, for each and every partition we will use row number. All right, then we are calculating running sum. Okay, after that we will calculate running sum, and here we are giving range, and lastly we are sorting by city, category, order date, order ID, and then we are showing the output. Okay, so I have written comments as well so that you can read and understand it. Now practice this in our notebook. So just delete this. It is running average example, right? Yeah, moving average, we need to delete this cell. Here we are performing partition by city, so we will delete this because we want to partition by city and category pair. So we will paste this all the code all at once. Control C. Control V. Then I hope this will work. Just run it. It's running absolutely fine. Okay, so now we have partitions for category and city pair. Okay, and then we have calculated ranks using this row number function. Then we have calculated running sum of amounts. Next topic is joins. So Spider-Man is asking, do we have SQL like join in Apache Spark? So answer is yes. For example, let's say we want to perform inner join. So we all know that what inner join does. It will combine rows from two columns. Combine rows from two tables where there is match in both the tables. Okay. So for example, look at these two tables, customer table and order table. So we have one common column like customer ID. So customer ID is present in both the tables, but we are performing inner join. So we will get only rows where customer ID is matching. For example, one customer ID 1 is present in both the tables, so we will get that row. Customer ID 2 is also present in both the tables, so we will get that row. Customer ID 3 is only present in first table, not second table, so we will not get that row. So let's check how the output will look like 1 and 2. Alright, now quickly check the code. Okay, so for window functions we have used earlier sample data, but for this join we will create new sample data frame in our Databricks notebook. So what is this? This is just a list of Python tuples which represents each and every row in customers table. Now this is list of tuple representing each and every row in orders table. Now we will convert this Python tuple into Spark data frame using this spark.createDataFrame function or method. So our table name will be this, and the column names will be this, customer ID, name, city. Same for orders table. Order table name will be this and column names will be this, order ID, customer ID, amount. Then we will perform inner join. So this is first data frame. We want to perform inner join on second data frame where our customer ID from first data frame should be equal to customer ID from second data frame. Okay, then we will show the output. So we will use brand new cell because we are not using old data frame, okay, which we used in window functions. So for join we will create separate data frame. Just copy it. First we will create our data frame. So do not copy the inner join code. Copy, paste. Now run. Okay, so our sample data frames are ready. These two data frames, order and customers. Now we will write the code for inner join. Control V. We should get customer ID 1 and 2 rows. Okay, because they are matching in both the tables. Alright, the result is as expected. Now next topic is shuffling. So Spider-Man is asking, I know that data frame is a list of data spread across the nodes in the cluster. Alright, but when we use operations like group by, order by or join, we will move data from one node to another. Okay, because in one node some other partition will be there, in some different node let's say order partition will be there, but we are performing join. So at that time we need to combine these both the tables, okay, so that we can match the customer ID or whatever the matching key is. Okay, so for that we will move data from one node to another, then only we'll get the result of operations like join. So how does this happen in Spark cluster? So the solution is shuffling. Okay, Spark will shuffle the data in from one node to another so that they can match the matching key. for example customer ID in our case. So Spark will need to shuffle the data so that they can perform join and data will be ready for our next operation. So what is the definition of shuffling? Moving the data from one node to another so that related rows comes together. Alright. Now next is broadcast join. So Spider-Man is saying, in my earlier join, which was normal join, I performed inner join. So both the tables were shuffled across the cluster and the operation was very slow. So he's asking, is there any alternative way for performing join so that operation will be little bit faster? And he is also mentioning one of his table size is less than 10 MB. So we were using order table and customer table. So customer table size was less than 10 MB. So what is the solution? Solution is broadcast join. So at the left hand side in second diagram you can see it is Apache Spark cluster. So one is master node and others are worker nodes. Worker nodes are partition of different tables. So top two are partition of order and remaining are partition of address table. So what we can do, our customer table size is less. So we will just broadcast the copies of customer table in all the partitions. Okay. So as you can see in each and every partition at the bottom side, customer tables is also present. So here for matching the keys of order and customer table, we do not need to shuffle because second table is already present in each and every partition. So we are not shuffling the data here. Okay. The order ID of the order table will match the order ID of customer table and our inner join will be performed without even shuffling because we are already broadcasting the copy in all the partitions. So what is the definition of broadcast join? If your one table is small, Spark can broadcast it to all the worker nodes. Okay, this is called broadcast join. So let's quickly check the code. So we want to perform inner join on orders table with customers table where our customer ID from order table should match the customer ID from customer table. Alright, and then just we will show the output. Here we are using customer ID as common key in both the tables. Okay, so just quickly check the code. So we will remove this normal join and now we will try broadcast join. df underscore orders is not defined. Okay, so our data frame name is df underscore customers and df underscore orders. Is not defined. Why is that? I don't know. Let me run this again. So that our data frame will be created again. It is run. Now we will try this again. Yeah, now it is working completely fine, and operation is much faster because we are not performing any shuffle. We are just sending the copies of our small table, which is customer table, in all the cluster, so that shuffling is skipped. This is called broadcast join. Now, how can we register data frame as tables? So Spider-Man is saying, I am actually not good with Python, but I am very good in SQL. Okay. So is there any way so that I can query Spark data frames in SQL instead of Python? Okay. Basically, you want to replace Python. He is very good with SQL. So yeah, there is a way. So the solution is we will register our data frame as tables. Basically, we are saying, please treat my data frame as table so that I can query in SQL. Okay, because SQL is my strength. So please convert my data frame to table, like database table. Okay. So actually there are two ways we can do this. We want to register our data frame as table, but there are two techniques. Temporary view and second is global temporary view. In temporary view, that table will be used by current session only. Okay. In your current Spark session, there only you can use your registered table and you can query using SQL. But in global temporary view, your table will be shared by all the Spark sessions. Okay. So just remember, in temporary view, single Spark session, current Spark session, there you can use, and in global temporary view, your table will be shared in all the Spark sessions. So let's quickly check the code. So these are our two data frames which we have used in earlier example. Customer table and order table. I will show you that as well. See this. This is our customer data frame and this is our order data frame. I think we need to connect it, run it again. Alright. Now let's understand this code. First, we will try this technique using temporary views. Okay, we will register our data frame as table using temporary view. Means valid only for current Spark session. So nothing on our data frame, will use this method, this, and we will give a name to our table. Okay. So this is our data frame name and data frame name is converted into, this is our table name. Now we can query this using SQL. So same way we can do this. We can use the same method on our second data frame, which is df underscore orders, which we have created here. Okay, this and this. Then I will also show you how you can query them using SQL. Select star from table name, select star from table name, and finally we'll show the output. So let's quickly copy this. Control C, and control V. Okay, so you can see your data frame which is now converted to tables, and you can simply query them using SQL. Alright, so this is how you can convert your data frame into, you can register your data frame into table using this temporary view technique, which will be valid for this current single Spark session. Now we will quickly try another technique. Okay, so in this another technique, you just have in global temporary view technique, you will use this method. Okay, you will use this method for our two data frames, and then you just have to do one thing. You will use SQL same way, select star from table name. You just have to use this prefix global underscore temp. All right, select star from table name, just use this prefix dot table name, and in temporary view you don't have to use this, just select star from table name. So now quickly try this. Copy, control V. Why it is showing error? Couldn't find global temp. Let's try to run this. Okay, so actually it is not supported currently in our serverless cluster name, because we are actually using free version of Databricks. Okay, so some features can't be used here. Okay, but in the real world scenario, real world clusters, you can use this only. Before the table name you have to use this prefix and use this different method, so that your table can be shared across all the Spark sessions, not this single Spark session. Okay, so that's how you can register your data frame into table and use this SQL like query. What are the different file formats which we'll deal with in data engineering field? So there are three formats: CSV, JSON and Parquet. CSV means comma separated values. JSON is JavaScript object notation. So in the CSV format, data will be stored in plain text. Okay. In JSON format, data will be stored in key value pairs. And in Parquet format, data will be stored in binary format. Okay. It's not readable, not plain text. Okay. It's a binary columnar format. Now, advantage of CSV is it is good if you want to read the data in Excel or Notepad. Advantage of JSON is it is good for semi-structured data like logs. Advantage of Parquet format is it is very optimized and very compressed. Okay. So file size will be very lower in Parquet format. Now disadvantage of CSV is it takes the most storage as compared to JSON and Parquet. Okay, it takes more storage, so it is not at all preferred or good for Apache Spark data engineering. Now JSON is like medium. It takes less storage than CSV but more storage than Parquet. And disadvantages of Parquet is there is no disadvantage. Okay, it is the most preferred file format in data engineering. So from all these three, which one is preferred? Parquet format is preferred. It is optimized, it is compressed, so data processing will be very faster if you use this Parquet format. What is partition writes? Okay, so Spark basically split our data in different folders based on our column values. Okay, let's say in city column we have different cities like Delhi, Pune. Then values with city equal to Delhi will be stored in separate folder, and row values where city equal to Pune will be stored in different folder. Okay, so Spark will divide our values based on the column values. Okay, based on the column values, yeah. So in different folders Spark will split our data. So let's say city equal to Delhi will be stored in separate partition, city equal to Pune, those rows will be stored in separate partition. It is very useful because Spark will only scan particular partitions. Okay, so let's say you want data where city equal to Delhi, you want to query that. So instead of like querying, scanning each and every complete data frame, okay, instead of scanning complete data frame, it will only scan those separate partitions. Okay, where city equal to Delhi, it will just scan that partition and it will give you result very faster. Okay, so partition writes means Spark will split our data in different folders based on our column values. All right, now what is coalesced writes? So now our Spider-Man is facing some issue. He's saying my Spark jobs are creating too many small files, output files. He doesn't want those small files. He wants fewer but bigger files. Because too many small files will slow down your Spark reading operation. Okay. I will repeat one more time. Spider-Man is saying my Spark jobs are creating too many small files. I don't want that. I want fewer files, and even if they are bigger, that will be fine, because too many small files will slow down your reading operation in Spark applications. Okay, so what is the definition of coalesced writes? It will control the number of output files in Spark. Instead of, by default, your Spark will give many number of smaller output files, but if you use coalesced writes, it will give you fewer and large files. So in the left hand side you can see many small multiple files are there, and after applying coalesced writes there are fewer output files and they are large in size. That's fine. Okay, so this is our coalesced writes. It controls the number of output files in Spark. Next is how we can handle semi-structured or nested JSON data with Explode. So first let's see what is nested JSON. So Spider-Man is saying I was trying to process JSON data with Spark. So his JSON data often has array inside array or object inside objects, means nested arrays or nested objects. Okay, so that's why he's facing some issue in Spark. So you can check that nested JSON. It is shown in the diagram in the orders key. It is storing multiple order arrays. Okay. So why it is giving error? The thing Spark likes the most is it likes to work with tabular data. Okay. It likes row and columns data to process. But instead of row and column data, if you are giving nested JSON like object inside object or array inside array, then it will give error. So like this, in orders, you can see it is storing in order column arrays. Okay, in orders column, it is storing arrays instead of single value. That is why Spark cannot query this. It will definitely throw an error. So what is the solution on this? Solution is explode function. What it will do? It will convert your array elements into individual rows. Okay. So in the left hand side you can see in the orders column we are storing array. Okay, array values we are storing. But once we apply explode function, it will convert those array values into separate individual rows. Okay, then Spark can query this very easily. Okay, so this is our explode function. What is the definition again? It will convert array elements into individual rows because Spark likes to work with tabular data in row and columns. It does not like nested JSON like array inside array or objects inside objects. It only likes single values in each and every column. So once we use explode function, it will convert array values into individual rows. Okay.